Welcome back, guys. So this is question 2.8 and 2.9. Today we are going to solve both of them as both of them are closely relevant with each other. So let us go through question 2.8 first. So according to the statement of this question, is the interconnection in figure P2.8 valid or not? Explain. Okay, so this is P2.8 and we have to see that whether this is valid or not, and B is, can you find the total energy developed in this circuit? Okay, so this is the second part of it. So first of all, let us see that whether this one is valid or not. So this is the common point here. This is the voltage source, the current source, this one is the source as well, and these are the two sources here. So we can see that here the voltage is VA, which can be drawn just like here as well. Okay, this one is the dependent source, this is here, this is here, and we have it here. Okay, so this is the current source, the voltage source, the current source here as well, and the voltage source, and this is the current source, and this one is the dependent upon this I1, and therefore this one is the current dependent current source. Okay, so this is the dependent current source which depends upon this current. We can see that here these all are connected in parallel, and these are not the constant sources, and these can adjust their voltages according to the current flowing through them. Okay, so therefore in order to see that what are the voltages across them, so let me have here VA, let me have here VB, and let me have here VC. So if the circuit is valid, it means that VC is equal to what? VA with this 20 volts, and it is equal to VB with this 30 volt. Okay, but why did I not write this 30 volts and this 20 volt? Because we don't know the polarities of this VA and VB. So therefore in order to do so, let me have first current. Okay, so this is the supposed current and this is the second current here. Both of the currents should be equal in direction. If this one is in the clockwise direction, the other one should also be in the clockwise direction. Okay, so we can see here that this is negative, this is positive, and as the direction of this current and this current, these two are in opposite with each other, so therefore one current is flowing through it like this one, and the other one from the other one, the actual direction is this one. So therefore the polarities of both of them will be opposite than each other. So therefore the polarity across this one will be what? It will be negative and positive, because this is positive negative, it will be negative positive. Okay, so therefore applying here the concept, and we want here the positive and here the negative because of these signs, so therefore this one will be the positive one while this one will be the negative one. So this one minus this one, if you apply the KVL through this one, so it will be VA minus 20 volts. Okay, so this is through this branch. Similarly in this branch we can see that what is the voltage here, this is the current which we have supposed, and here it will go through this positive, come out of this one. Similarly the actual direction of current is also this one. Okay, so therefore the polarities of both of them will remain the same, because this should remain the positive, this should be negative because of this polarity, and here it will be what? It will be plus minus, because here it is also plus minus. So therefore applying KVL across this branch, what will we get? These two voltages will add with each other, so VB plus 30 volts. Okay, so here this shows that this one is the valid circuit. Okay, so this is the validity of circuit. Can you explain the total, can you find the total energy developed in the circuit? Explain. So in order to find the total energy in this circuit, we must have the currents which are known. Okay, so this is the current, but the voltage across this source, the voltage across this source, and this current, these are unknown. In order to find them out, we have to solve this equation, which can have many solutions as well. Okay, if we don't know the values of these voltages, it is not possible for us to find the total energies developed here. Okay, so that is the solution of the question which we were solving, and this was 2.8. Similarly, in question 2.9, the statement of this question is, if the interconnection in figure P2.9 is valid, find the total power developed in the circuit. If the interconnection is not valid, explain why. So first of all, we have to see that whether this interconnection is valid or not. So therefore, this one is what these three are, this one, and this one. You can see, let me write here as well. So this is here, this one is here. Okay, so this is plus minus 40 volts, this is the current source here, this is the dependent source. Okay, and this one is the current dependent voltage source because of these polarities, current dependent voltage source, and this is the independent voltage source here as well. This is the 60 volts, and another voltage source which is connected here within these two branches here as well. So this is 30 volts. Okay, so the voltage must remain same between all of them, because if this is VA, so VA is 30 volts, because here across these two nodes the voltage is 30 volts. Okay, similarly here, in order to see that this is 1800 Ix, so 1800 Ix is here, and what is the value of Ix, as it is flowing through this branch, so therefore the value of Ix is 50 milliamps. Okay, or that is 0.05 amps. Okay, putting it here, okay, what will we get? The voltage across it, let me have it here. So the voltage across it, let me call it VA. So the value of VA would be 1800 multiplied by 50 multiplied by 10 to the power minus 3, because of this Ix which is here. So finding it out, it will be what? It will be 180 multiplied by 50 divided by 1000. So these two will cancel out here. 18.5 is 90 divided by 10, so this will be 9. So the voltage here is 9. So applying the KVL across this branch, let me use this one. So in this branch, if we apply the KVL, it will be what? It will be VA plus 60. The value of VA is known, that is 9 plus 60, which is 69, which is showing that the voltage VA here is what? This is 69 volts, which is in contrast different than the actual voltage which is here. Okay, so therefore the two different voltages are connected in parallel with each other, which is impossible. Okay, which is impossible for the validity of a circuit. So that's why this circuit is invalid circuit. So that's it for today, in which we have discussed two very complicated circuits and saw that how to find the polarities of different sources if the polarities are unknown, and also the validity of the circuits as well. Also we have seen the current dependent current source as it is given here, and the current dependent voltage source which is here as well. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.